So we've been given a function and we need to sketch it and find the range. So as you can see, it's in our function notation form in which we have our domain, our codomain, and right here we're being told that f of x equals x of sine x squared plus 5. Now we haven't yet talked about sine and cos, so don't freak out too much. The reason why we're doing it here is to really show you that you can use your CAS to graph something that you have no idea what it's going to look like. So let's begin to give it a graph on our CAS. So I'm going to come here and push this button, which is going to tell me, bring up my graph. And now I'm going to type in my function. Now I'm going to do this the wrong way first to show you what not to do. So many of us, by looking here, might just go, all right, so I have x, then I have sine, then I have x squared plus 5, close my brackets. Now when I hit enter, nothing is going to come up. And there you go, nothing. Now, why didn't that work? The reason why it didn't work is because, as you can see here, sine is in italics, and we don't want that to be the case. We don't want it to be in italics. And the reason why it is because we haven't told it x times sine. So if I put in a times here, times, you can now see that my sine is no longer in italics. So now when I hit enter, it graphs it. Perfect. So that's the first thing you need to make sure you get correct. The next thing is radians or degrees. Now again, we haven't touched this yet in our course, so I'm not going to talk about it too much. But as you can see here, by clicking this button, you can transfer between degrees and radians. Now we want it to be in radians. Don't worry too much about that at the moment. We're going to touch on that later on in the course, but just know for this example, we want it to be in radians. Having done that now, we need to restrict our domain to this, -2 to 2.86. So how are we going to do that? We're going to go tab, we're going to bring back our function. Now we're going to hit control equals, and then we're going to hit this vertical bar, which means such that. And then we can put in our domain, which is -2 to 2.86 inclusive, which means I have 2 square brackets. So that means I'm including both of those points. So now let me type that in. I have -2. Then I'm going to go control equals less than or equal to x. Control equals less than or equal to, then 2.86. Then I'm going to hit enter and I'm going to get this. Let me get rid of this for the time being. We don't need it. It's gone. Now I want to zoom in. So I'm going to go menu. I'm going to go window zoom, and I like using box. There are other options, but I like box the best. Then we're going to hit there, and we want just that. Perfect. So now we have a nice view of our graph. Now, the very first thing that it's asking us to do is give it a sketch. So if you were to actually give this a proper graph, let's say you're in a test and you had to graph this precisely, you would need to find this point, this endpoint, this endpoint, and then you would need to find each x-intercept, which would take a lot of time. And I'm just going to show you the process by which you would do that. So let's begin. To find this point here, the endpoint, what you should realize is that it is a maximum value in this general region here. So if I go menu and I go analyze graph and then bring up maximum and then go, let's start my lower bound here and stop here. Now, if you were to go too far, it's not going to give you that value. You need to make sure that you're in this region, so it gives it to you there. Perfect. Next, we're going to find this value, and again, as you can see, it's going to be a maximum value. It's just going to be the same process, menu, analyze graph, maximum, and then we're just going to go there to there, and we get it. Perfect. Next, we need to find the x-intercepts. Now we have 1, 2, 3, 4, 5. The traditional way that you find your x-intercept is by going menu, analyze graph, 0. You click that. Then if I go lower bound, upper bound, it's going to give you 1. Then you'd have to repeat that process. You'd go menu, you'd go analyze graph, you'd go 0. Then you'd do it again. Whoopsie daisy. From there to there, and it's going to give you a value. Then you repeat it again and again and again. I want to show you a little trick. So if we just delete these for the time being, let's get rid of those. And let's bring up this and let's put in a new function. Let's put f of 2 of x equals 0. Now, hopefully you realize that that's just y equals 0, which is just a horizontal line that lays on top of my x-axis. So now if I wanted to find the x-intercepts of this blue graph, all I would need to find is where it intercepts with this red line. And the way you can do that is through a little trick. You can go Menu and go to Geometry. Then in Geometry, go Points and Lines. And then in Points and Lines, go Intersection Points. Click that. Then click your blue graph, click your red line, and look at that. It's going to give you all of them at the same time, which is great. Then you can just separate them out to get a clear view. Whoops. Oh, it doesn't want to come with me. Come on, 0, 0. All right, we're going to leave it there because it doesn't want to. Whoop, there we go. That's there. That's there. And that's there. So there you go. We have found the endpoints and we have found the x-intercepts. So now if you were to come to draw this, now if you were to draw it properly, you would have to put in all that information. I'm just going to give it a rough sketch because that would take me way too long to put in all that information. So we're beginning there, we're going down, we're going up, we're going through the origin, we're going up again, we're going down, then we're coming up. All right, that's a pretty ugly looking graph. And we're stopping there. Let's pretend that looks good. All right, and then of course, if this was a real test, you'd have to put in all these points. But the main aim of what we're doing is trying to find our range. So let's clear the graph and deal with that. So I'm gonna go here, I'm gonna go escape, and I'm just gonna delete these points just to clear it up for us so we can really look at what we're doing. All right, I'll get rid of that as well. So we've got this, and we need to find our range. Now we know that our range is the set of all the y values. So in other words, we're going to go from the lowest y value to the highest y value. So what the lowest y value is quite clear. It's going to be here. So what I have to do is go Menu, I'm going to go Analyze Graph, and I'm going to go Minimum, and then just give it a lower bound there, upper bound there, and I found it. So it's going to be negative 2.46. So then I come here. So it's going to be here, and I'm going to include that point. So I'm going to put a square brackets, negative 2.46. Now, let's say you couldn't tell when you're finding your maximum value if it's here or if it's here. How could you find out? Well, a way in which you could do it is by going Control. We're going to open up a new page. Whoopsie daisy, that's not what I wanted to do. We're going to open up Calculator. Now, I'm going to go Menu, Calculus, Function Maximum. Now remember that I've saved it as, if we bring up our tab, I've saved it as f1 of x. So if I go f1, it's bold because I've defined it in my graph of x, and I want to find the maximum value, and I wanted to give it to me as the x value. So the x value, which corresponds to my maximum y value. You can't just go straight for the y value, unfortunately. Then hit Enter. And it's going to say it's x equals 1.737. So now if I want to find the corresponding y value for that, I'm going to go F1, it's bold because it's defined, and then put in this right here. So I could just copy that and paste it. And this warning is just telling us that it is an approximate. It's approximate. It's obtained using approximate arithmetic. But that's all right. We hit Enter. So just realize that that warning does exist. So now we have 1.7139. So it's telling me that this is my coordinate for my maximum value. So now if I come here and I go, let me get rid of that. It's kind of clear that this is my maximum. When you look at it, this does look higher. So that point should be the same as this point right here. So I'm going to go Menu, I'm going to go Analyze Graph, I'm going to go Maximum, and I'm going to find it from here to here, And lo and behold, we are correct. 1.74, 1.71, 1.74, 1.71. So that means this is my maximum. So my maximum y value is going to be 1.71. So I come here and I write in 1.71. And again, it's going to be a square bracket because I am including it. It is included. So my lowest, my minimum y value is there. My maximum y value is there. This is what your range should look like. Hopefully this was helpful in answering this question. And also that I've equipped you with some tricks and tips for using your CAS.